Hey there, welcome back to CMTEQ channel. So here we've got another tricky yet powerful problem for electrical engineering students and professionals alike. So this transmission line problem actually demonstrates a very simple yet powerful principle of how most electrical circuits operate. So you don't want to miss this, okay? Because understanding how that principle operates help you eliminate a lot of problems. You will be making very informative assumption while solving your circuit. Here we've got a pi method. I've already solved one or two tutorial regarding the pi method, so please check the description box. There are full tutorial about the pi method. This is why here I'm not going to solve this entire problem. I'll be just giving pointers, okay? What's going on here in this simple pi method circuit here? They say we need to determine the voltage at the sending end of a 110 kilovolt three-phase system. Now, this 110 kilovolt is a receiving end voltage, okay? This transmission line is delivering about 30 megawatt at a power factor of 0.8 lagging, right? Typical transmission line system. Now, each conductor of the three-phase system, as we can see, 1, 2, and 3 conductors. Now, they all have a resistance of 20 ohm and an inductive reactance of 46 ohm. Now, these are line parameters that cause voltage drop on your system, on your transmission line. And there is a capacitive reactance of 2.65 kilo ohm. Now, this is to model the pi method. As you've seen, I've represented capacitors here. These capacitors, they actually occur across the entire transmission line, right? Now, in a pi method, you simplify it, you represent it by just two capacitors at two ends of the circuit, okay? Now, what's going on here? They say if the sending end voltage remain constant. Now, the key here, constant, it does not change. We need to determine the percentage rise in receiving end voltage when the load is what? Thrown off, okay? So when you disconnect the load, what will be the percentage rise in the receiving end when the load is turned off? So how do you go about solving this? Step one, you calculate your line parameters. You've got your impedance, you convert it into polar form. Then you've got your XC, which is the capacitive reactance. For the pi method, you convert it into the admittance, basically the inverse of the capacitive reactance. Now you have your admittance. But now because we're dealing with the pi method here, you need to divide it by 2, okay? Because you're going to place a capacitance on each end of the line. Great stuff. Now step 2, you need to calculate the receiving end voltage. Now this is the phase voltage because all your calculation, they have to be made in phase parameters, phase values, okay? Because you basically calculating for one phase here, just this one phase, okay? And you will assume that all the phases are identical, which means the values are going to be exactly the same, so you don't have to calculate for all three of them, okay? That's how you solve three-phase systems, okay? Now you moving on. By the way, please, if you find this useful, don't forget to thumbs up and share to your social media network. That will be highly appreciated. I thank you so very much. So your phase voltage, basically the line voltage divided by the square root of 3. That's fine. And you need to calculate your load current. So that basically dividing your power here, okay, by the square root of 3 times your line voltage and the power factor. So that gives you this line current or the load current with this angle. You understand how we get this angle? Please watch the previous tutorial. So you basically take the power factor and you convert it to get the angle of the current. It's negative because the current is lagging. It's a lagging power factor. Great stuff. Then you need to apply the pi method. Since you now have everything that you need to actually get this pi method circuit going, you can then go ahead and apply your pi method. Okay, so now you've gone through the steps and you've arrived to your pi model here. So now what do you then need to do to determine the percentage rise at a receiving end voltage? Now, the first thing you need to find is the sending end voltage here. Now, this is why I said earlier you need to watch the pi method tutorial so that you can get a sending end voltage, because the process is exactly the same. That's why I'm not doing it here. Now, just so you know, you're working in reverse mode here. Now you've got a model, you've got all your parameters, so you know the voltage here at the receiving end phase is 63.51 kilovolt. Okay, we've calculated, basically we got it there. Now you know that this voltage is the same voltage across the shunt capacitance here, right? So which means you can find IC. Now once you find IC, you can apply Kirchhoff current law here to find the current in this line. You can name this current I3. Now when you find I3, that means you can find the voltage drop across the series impedance, since you've got your impedance here. Now once you find that impedance, you can find the voltage drop across it, and you can just take that voltage drop, you add it with this voltage, and that will give you the voltage across this shunt here, and that will also help you find the current through the shunt, and you can find the sending end current. But as soon as you find this voltage, it means you found the sending end voltage, because they are equal, right? Parallel circuit share the same voltage, right? When the circuit is operating normally here, you're going to have this current IR will be flowing, and that current IR is what causing the voltage drop here, called VZ. Okay, now it's VZ that is going to be subtracted from the constant sending end voltage, and that will result in a lower receiving end voltage. That's a principle we all know. Okay, but now they say when the switch is turned off, basically when the load is disconnected, this sending end voltage, this receiving end voltage is going to rise to a specific percentage. You need to find that percentage rise. That's the question. So what is the principle? If you disconnect the circuit, you cut off here, what's going to happen? The load current is going to be zero. The current is not going to flow anymore. Load shedding, the power have been cut off. Okay, which means if you don't have a backup system, you are sitting in the dark, right? So now what's going to happen? There will not be current here. This I3 is also going to be zero, which means the voltage drop is also going to be zero. Okay, it's going to be zero. Okay, now since the voltage drop is equal to zero here, what's then going to happen? The constant sending end voltage here is going to be the same one here, because these two shunt capacitance, they're now going to have the same voltage across them, since there is no voltage drop here. Okay, that's basically mean the voltage at the receiving end is going to be exactly the same. So Vs is gonna be equal to Vr when the switch is off. But obviously it's a receiving end voltage with a load disconnected. But now how do you find that percentage rise? To find the percentage rise, you then going to say, okay, so let's just say percentage, it's now going to be equal to this Vs, that is equal to Vr, this voltage that will be across here and here. You take that voltage, you minus this voltage, which we already found to be 63.5 kilovolt, and you divide it by this voltage, 63.5 kilovolt. Okay, and you're going to get a X percentage here. Now that percentage is the percentage rise. So basically they're telling you right now, when the switch is closed, VR is 63.5 kilovolt, but as soon as the switch is disconnected, the receiving end voltage is going to become whatever the value of the sending end voltage is going to be, which we do not know. So that is what you need to determine, and once you determine the voltage at the sending end, then you're going to find that percentage raised. So from 63.5 to whatever value it is, that will be the percentage where the receiving end voltage is going to rise. So that basically the tricky problem that they were asking there. So if you do not know this simple principle, you're now going to be scratching and trying to find, hey, what's going on here? But actually just disconnecting, no current flow, which means these two voltages become equal. So this principle can be applied in every electrical circuit that you want to analyze. So that is it, guys, for this tutorial. I hope you find it useful. Please make sure you give the thumbs up and subscribe to CMTEQ channel. That will be highly appreciated. Please stay tuned for more tutorial on other power system topics, especially power factory analysis, which I've been getting lots of requests on. So I have tutorial coming up in the pipelines about power factories and obviously other topics as well. Until next time, cheers.